Hello and welcome. Today, we are diving into a huge challenge, one that I'm sure keeps a lot of cloud architects up at night. And that's how to make sense of these incredibly complex, sprawling multi-cloud environments. So, how do we get a handle on it? Let's find out.
I mean, this is the fundamental question, isn't it? Your applications, your data, it's all scattered. You've got some stuff in AWS, some in Azure, maybe Google Cloud, maybe even a data center on-prem. So how in the world do you get a single coherent picture of what's actually happening everywhere?
Okay, before we go any further, let's make sure we're all on the same page with our key term, observability. This is way more than just looking at a dashboard. It's the ability to ask any question about your system and get a real answer just by looking at the data it's already putting out, the logs, metrics, and traces. That's the goal.
So here's our game plan for today. First, we're going to step into what I call the multi-cloud maze to really get the lay of the land. Then we'll look at the centralization dream, the obvious first step for a lot of people. After that, we'll compare the two main paths, central versus federated. We'll get visual, see how the data actually flows, and wrap it all up with the architect's final choice.
All right, let's kick things off with the problem itself, the multi-cloud maze. Just think about it for a second. Every cloud provider is kind of its own little universe, right? They all have their own tools, their own data formats, their own APIs, and this just naturally creates silos, making that single unified view we all want feel almost impossible to get. And this is the perfect analogy. It really is like trying to finish a massive jigsaw puzzle, but all the pieces are in different houses all over town. You just can't see the whole picture because you can't get everything into the same room. That right there is the core of the multi-cloud observability challenge. So what's the most intuitive solution to that puzzle problem? Well, obviously, you try to bring all the pieces to one table, right? And that leads us directly to what we call the centralization dream. And you know what? It's a beautiful dream. This idea of a single pane of glass, one dashboard where every log, every metric from every single cloud is right there at your fingertips. It sounds so simple. It sounds perfect. But, and this is a big but, this dream can turn into a real nightmare, fast. And this is where that beautiful dream starts to fall apart. First off, you get hit with massive egress costs. That's what cloud providers charge you just to move your data out. Then there's data gravity and latency. The bigger your data set, the harder and slower it is to move. This whole approach can also lead to serious vendor lock-in with whatever central tool you picked. And finally, you end up duplicating tons of data, which means you're paying to store the same info in more than one place. It's a whole cascade of hidden problems. So this brings us to a major fork in the road. If the dream of centralization has this dark side, what's the alternative? This is where we need to understand the two primary architectural patterns for solving this problem. The difference between these two paths really just boils down to one simple idea. The centralized model, or the aggregate everything model, says, let's move all the data to one place so we can analyze it. The federated query model says the complete opposite. Leave the data exactly where it is, and send your questions, your queries, out to the data. Okay, so let's put these two models in the ring for a head-to-head comparison. By putting them right next to each other, we can really dig into the nitty-gritty, the critical trade-offs that every single architect needs to think about. So let's break this down. With the centralized model, data movement is super high, which, no surprise, leads to high egress and storage costs. Plus, your data has to leave its native cloud, which can be a huge headache for compliance and data sovereignty. Now, the federated model completely flips that script. Very low data movement, which means lower costs, and your data stays put. So what's the trade-off? Well, because you're querying across a network, federated queries can sometimes be a bit slower than querying data that's already sitting right next to the query engine. Reading a table is one thing, but actually seeing it in action is another. So now, let's visualize how the data and the queries physically move in each of these models. I promise this will make it all crystal clear. All right, let's trace the centralized flow step by step. It all starts pretty simply. Your data is being generated, your apps are spitting out logs and metrics inside Cloud A, Cloud B, and Cloud C. Business as usual. And now for the big, expensive move. All of that raw data, and we could be talking petabytes of it, gets copied and shipped out of each cloud, right across the public internet. You can practically hear the egress cost meter just spinning and spinning. And finally, everything lands in one giant central spot. This is where you get your single pane of glass. And yeah, queries here are going to be fast, absolutely. But you've paid a really steep price in cost and complexity just to get all that data into one room. This quote just nails it. To get an answer to your question, you physically move mountains of data to the place where your question is being asked. Remember that. Now, let's see how the other model works. All right, now for the federated flow, which completely flips this whole script. The process doesn't start with moving data at all. It starts with a question, a single query, sent from a central console. That small, lightweight query then gets sent out to each cloud. It travels to where the data already lives, and it asks each system to find the answer on its own home turf. And here's the magic. Each cloud processes that query locally and sends back only the result. So instead of terabytes of raw logs, you get back maybe a few kilobytes, just the answer itself. The massive haystack of data stays right where it is.
And there it is, the perfect contrast. This model is the polar opposite of the centralized approach. It's a fundamentally different way of thinking about getting information, and honestly, it's a model that feels built for the multi-cloud world we actually live in.
So, after comparing these two powerful but very different models, we finally arrive at the most important question. Which path is the right one for you?
And look, there is no single right answer here. The best architecture depends entirely on your specific needs. If your budget for data transfer is really tight, or if you have strict data sovereignty rules that say data can't leave a certain country, well, federation starts to look really attractive. But if you need the absolute fastest query speeds possible and you have the budget for it, centralization might be the right call. It's a classic engineering trade-off. And that leads us to one last, kind of provocative thought to leave you with. As we move towards a future with not just 2 or 3 clouds, but dozens of specialized services, edge locations, the whole shebang, will the very idea of a center become obsolete? Is a federated, decentralized approach the inevitable future of observability? Now that is a question worth thinking about. Thanks for joining us.